Hello class and welcome to Module 6. This module we get to learn a bit about visualization. Now in CIS189 you got a very light intro to using Matplotlib, but it was very light and I'd like to go a little bit further with that because I don't believe we had quite enough there to really get a lot of value out of it or see the value of it. So we're going to dig a little deeper here and show some what I consider to be really nice visualizations that you could share in, let's say, a meeting or across your team or whatever to give them an understanding of some set of data. Now, this is going to be a continuation of the analysis we did last week. If you recall, we were looking at that Kickstarter data and trying to get it into a format where we can better understand what is going on in that data. And we had kind of taken it to the point where, at least with the questions I was trying to answer, we couldn't probably go very further just by looking at tables of data. So now we are going to turn those into visuals because, as we all know, a picture is worth 1,000 words. The human mind is very good at looking at differences and seeing trends with a visual better than they are looking at data. So we're going to do that. So I'm going to keep my notebook in this view because both the cells get very large as well as the visuals I'm going to display are very large. So it doesn't make sense to put into that other mode that I'm normally in, although unfortunately it does look a little bit busier. I will try to make sure I highlight or point out where I'm at when I'm talking to make it a little bit easier to see. So with that, Module 6, starting with Topic 1. In Topic 1, it's just a data visualization primer. There's not a ton there, but there's a few links that you might want to follow to just get yourself caught up with visualization, just to see some of that before you start digging into actual code this module. There's no assignments there, there's no demonstrations there, just some good information. So from there, we go right into Topic 2, and all of the plots this week are going to be utilizing Matplotlib. It is by far the most commonly used library for visualizations in Python. However, it is not nearly the only one. This week we will be using this. Later in the semester, we're going to be using a different module called Bokeh that is good for doing online visualizations. But this week, we're just going to be sticking with Matplotlib. Many of the other libraries for visualizations are actually built on top of Matplotlib. So having an understanding of this module does give you a lot of understanding of the ones that are kind of built on top of it. Everything is built, let's say, in a similar way to how you do it with Matplotlib. So I'm going to start just by showing you the first few rows of that cell or that data frame that we had created at the end of last week, just so you can recall. So the data frame is called Kick Success by Backers. And you can see here, this is just the first 5 rows, but we've got it down to the groupings that we created of backer groups, or the buckets that we had created of backer groups, and the state of those campaigns. Now, of course, there's a lot more rows here. I'm just showing the first few, but you can see it's a fairly simple data frame, something that would be hopefully good to visualize. So I'm going to. So I'm going to just create a simple plot that counts each of these projects by the state that they are in. So I will end up with 4 groups that are counted up on a visual. So you can see in my cell here, first thing I have to do is import Matplotlib. I'm going to be using the submodule pyplot. The pyplot stuff inside of Matplotlib gives you a lot more options when you are setting up your plots. And you can see here, I'm going to grab Kick Success by Backers, the state column. So I'm counting the state column, dot value counts, which is how I count it. And then I'm going to plot that result. So I'm going to plot a bar, and I'm going to give it a title right away, Projects by Status. So if I run the cell, hopefully, there we go. You can see that I get this fairly simple chart. It shows my title, Projects by Status, and it gives me a count in a bar form of each one of the campaign statuses. So obviously successful is the most prevalent. So the majority here, by quite a bit, of campaigns are successful. Some are failed, some are canceled, some are live, some are suspended, starting from that down. Okay, well, that's cool. but not super informative because I'm really wanting to understand. The overall thing I've been trying to dig into is how these projects do by the number of backers. So if a project has more backers, is it more likely to succeed? So we're going to have to keep digging here. So in this next one, I am going to do some grouping on that frame. So you can see again, kick success by backers, and then I'm doing a group by, and I'm grouping by backer groups and state. So you can see if I do value counts on that and plot it again, I get this. Now, I did this just to show you, you don't always succeed here, but I have created another plot here where I have broken down those counts in each of the categories by state. So if you look, I mean, I can't even get it probably close enough, but if you look, this first group is the 0 to 501 successful, 0 to 501 failed, canceled, live, suspended. So not a good graph, not a good chart. I mean, you can kind of see, again, some piece of information here, but this isn't something you'd want to use. So we're going to have to keep going. As I said, that's kind of busy and hard to read. I'm going to make an adjustment to my data frame now so it's a little bit easier to plot because what I did there I didn't like. And sometimes adjusting the data is easier than trying to continue to update the plot itself. So this time I'm actually going to group my data frame by state and then by backer group. So I group it first, and then with that grouped frame, I group a subgroup. So each of the groups has a subgroup, and then I do counts on it. So you can see here, I'm creating another frame because I don't like to overwrite my frames. Kick result equals kick success by backers, and then group by first state, and then group by backer groups. So within each one of the states, it's going to then be grouped by backer groups, and then I'm going to take counts. So what I get is a count for each state and backer group combination, and then I print the result in the shape so you can see. This is a nice looking view here because I can very quickly see in the canceled state, 0 to 50, there are 4,130. If I wanted to look at just 0 to 50, I could quickly go, okay, there's 21,000 here, there's 370 here, et cetera, et cetera. Again, this isn't a visual, but it is getting to the point where you can see that it is organized in a way that will visualize well. So that looks really nice. I'm going to keep going. Before I go ahead and do a visual on this, I want to first do what's called a reset index. And I can't remember if we looked at that last week or not. But the nice thing about a reset index is I can take a grouped frame. And when I do a reset index, it goes from being a grouped frame to just being a regular frame, so that I don't have to worry about the levels that are there anymore. It just kind of simplifies it, flattens it down to, a WYSIWYG, what you see is what you get, frame. You don't have to do this again for plotting, but it makes a lot of it easier because I don't have to worry about making sure I've got the right grouping set up each time I go through these plots, because I already see what I want to plot is right here. I don't want to have to worry about the grouping anymore. I just want to work with this data. So if I run this again, you can see the only difference visually here is that each one of the states is now labeled. So you can see state canceled, whereas before you can see, because it was grouping, all of this was under state canceled, but it was only labeled once. But now everything's labeled, and this is a flat, just a normal data frame. It is no longer grouping. I can't dig into the groups anymore because it is just a standard data frame. So with all that set up now, I'm going to create some nicer visuals. First, just to get us started, I'm going to visualize the successful campaign counts by backer groups, because I want to see if how many of them, I guess, are successful based on what groups they're in. And this won't give us a ton of information, but it'll get us started. So these repeated imports are not necessary. I do them because if you were to copy a section of code out of Blackboard and use it, then you don't have to worry about getting your import there again. So it's not necessary in every cell. I just do it just because. But continuing on, I'm assigning a variable called figure1. And with that, I'm going to take from my kick something frame, which is what I called my flattened grouped frame. I'm going to plot. I want to plot everything where the state equals successful, which is perfect, right? Because I just want to see successful in this case. So that's the syntax you'd use. Give me everything in the data frame kick something where kick something, column state equals successful. So it'll ignore everything else. And then I'm just going to label my columns here because when I flattened my data frame, my column labels weren't quite right. So I'm assigning my columns as state, backer groups, and backer sum. And then I'm going to print figure 1 here just so you could see it. I'll just run this so I can show you that. You can see here's the data I'm about to plot, all nice and set up. You can see the only group is the only state is successful, as we should expect. That's what that was right here. And then I'm going to tell it what my labels are because it's not necessarily going to use labels that I like. I don't want this, 10,000 to 10 million. So I simplify it by saying just 10,001 plus. But textually, I like this better. So I'm assigning my labels. And then I do my plotting. I say, give me a bar plot using my labels here and my data, which I assigned here. And then it's backer sum, so I want to use the count on my y-axis. So my x-axis is labels, my y-axis is my backer sum column. And then plot x ticks is how I tell it I can adjust the angle of my labels. So you can see here, if you do this by default, the labels are horizontal, and because I have such long labels, they overlap each other, which doesn't look good. So I just went ahead and angled them at a 45. Another option here is I could have turned my whole chart 90 degrees so that my labels would be along the left edge for my x-axis. But in this case, it feels like the counts should be going vertical just because it's a numerical count thing. I think it should be up and down. So I made this choice. And then this print xx or print hash just is to stop it from putting some goofy output that I didn't like. So there you go. So here's my data. Here's my chart. Okay, now we're getting somewhere. I've got, I can see obviously the counts of successful campaigns are going to be larger for groups that have less than 51. That still makes sense to me because a lot of campaigns probably don't get a ton of backers. Maybe there are campaigns where they're only looking for 100 backers or 75 backers, and so they can still be successful without a ton. There aren't going to be, no matter how successful they are, there aren't going to be a ton of campaigns with 10,000 or 10,000 backers. So that all makes sense to me. To dig it further, I'd like to now do that same thing, except I want to see it for my failed campaigns, my canceled campaigns, and my suspended campaigns. And I can do all of this on one output using subplots. And subplots can be really nice. It's a little more difficult to get comfortable with because you're kind of working with multiple things at once, but it's not too bad. So in this next one, I'm going to create 4 subplots, and each of the subplots is going to be for one of the states that I want to visualize. And I'm going to just step through the code here. Again, I'm doing my imports, not necessary, but I'm doing it. Here I am assigning my RC params. I wanted to do this because I wanted my charts to be bigger. Just for output purposes or visual purposes, I thought they should be larger. Now, when I set this parameter like this, it will affect in this case, my entire notebook. So all of the cells in my notebook will be updated, or if you were working in PyCharm, it would affect your entire program. And sometimes that can be kind of annoying because in some places maybe you wanted a smaller chart, in some places you needed a larger one, depending on what you were trying to visualize. But you can use a width parameter here where you can say width plt.rcparams equals 150 and then tab all of your code in underneath it, so it'll only affect this one case. I'm not going to do that here, but you could have done that. And this is how I'm going to create my empty subplots. So I'm going to create 2 variables called fig and axs, and you'll see down below that I use both. And then I'm going to assign them plt.subplots. And this is where I say how many subplots I want and what shape I want them to take. So you can see 2 by 2. With everything, just like everything else, 2 is going to be my columns, and the other 2 is going to be my rows. So I get 2 tall by 2 wide. So I'm going to get a total of 4 subplots here. And I can also affect the size of each of my subplots here. I didn't have to do this because I didn't actually change any of them here, but I could actually have made, plot 1, or, the one in the upper left corner I could have made larger. And the one in the bottom right corner I could have made smaller. Maybe if you had a scenario where you wanted to emphasize one of your plots, maybe you could make one gigantic and then the other 3 kind of small around it. You can do things like that. In this case, I think they're all the same importance, so I'm just going to make them all the same size. However, I just wanted to show you that there so you could try adjusting your plot sizes if you wanted to. Continuing on, I have to create my 4 sets of data here, so everything's kind of done 4 times. So figure 1, 2, 3, 4, you can see that they are assigned states. Figure 1 is successful, figure 2 is failed, figure 3 is canceled, and figure 4 is suspended. It's just pulling the parts of that data frame into variables that can be plotted. And then unfortunately, I didn't figure out a prettier way to do this, but I just assigned the column names to each one because they all have the same column names. And I'm using my labels variable here again. And then down here is where I do my actual plotting. Now, this is where the understanding that vertical is the first axis and horizontal is the second axis is really important, because this is how I'm telling each of my plots what they are. And I have to make sure I get these numbers right, otherwise I'm going to mess up how my plots look, or they aren't going to do what I expect them to. So 0, 0 is my upper left. I'm going to, it's going to be called plot figure 1 back or sum. So I'm doing figure 1, which is my first set of data here, which is my successful campaigns. And then I'm going to, on my y-axis, is going to be back or sum. And then I'm going to shut off my labels on my x-axis, because it's going to be a mess if I try to do that. You'll see that in a minute. And then I give it a title, because otherwise it's going to be hard to understand what's going on. I'm titling it successful. And then I just repeat it. So this is the first row, it'd be the upper right plot. And then this is the lower left plot is canceled. And then the lower right plot is suspended. So this, you can see I get these 4 nice subplots. I used a line chart this time because I wanted to show you different variations. But you can see the first one is successful, second one's failed, third one here is canceled, the fourth one's suspended. And I can kind of see the shape of this. So I don't have my X labels here, but going to the right would be more backers on each one of these charts. You can see successful. You got to remember, this is just counts. So it looks like canceled. You get less canceled quickly as they get more backers. You kind of get a similar amount of suspended, which is interesting. And then failed is following kind of the similar canceled. However, I don't have quite enough information here. Like, this isn't showing me really what I want. It's actually a bit misleading, because if you can see, this is successful campaigns, and your labels here, your Y is 30,000. Over here, suspended looks just as big, but it's only 100. So these aren't really fair comparisons. And if you're expecting someone to look at this visually and quickly pull information from it, they are going to get the wrong information, because they are going to see these as all similar. And then when they dig deeper, they're going to go, well, this isn't anywhere close. And so you're going to kind of lose trust. Your audience is not going to trust your charts because you've done something misleading. So we're going to have to do more than this, obviously. Continuing here, as I said, looks misleading because each of the groups is not actually the same size. So I'm going to fix this by assigning the height of each cell independently, so they don't all take that same height. So a lot of this is similar. There's a lot of code here, but it's as similar as before. Nothing's changed here. It's all the same. But down here, when I'm doing my plotting, again, all this is the same. However, the only thing I'm adding here is setting my Y limit. So you can see the first one I'm setting them all to 0 to 40,000. So really I'm saying all of them should have the same maximum Y axis. So they should all go up to 40,000. No matter what the data says, they should all go up to 40,000. Again, I get a much more realistic view. So there are a lot more successful campaigns, as we know. There are some failed, there are a few canceled, and there are essentially none that are suspended. This is a more realistic view, although still not beautiful. But I feel like this would be more trusted by my audience, because it is a true indication of what's going on. So I could go a little bit further. First here, I'm going to show you, I could have done, you saw how I set the Y limit independently for each one. I could have also used a Sherry parameter, which I'll do here. And then I can pretty things up by giving them different color and some nicer titling. So the only things that have changed, again, there's a lot of code here. The only things that have changed here is I've added this Sherry variable, which is col, which means I'm saying all of the charts should just follow the same Y axis. So it'll just go to whichever one is the largest range, and that will be assigned to all of them, which is really what I did in the previous one. And it's just another way to do it. Nothing's changed here, but down here I've added in a super title, which is just a title over the top of all of the subplots to give the whole thing a label. And then I've also added in a color variable here. So I got green, red, blue, yellow. And if I run this, again, similar as before, but I got that nice misspelled campaign status counts by backers, and then each of the colors are shown there. Looks a little bit nicer, maybe a little more professional. This isn't great here. I'd have to clean this up, but I could. Okay, what else can we do here? I'm still missing those x-axis labels, and I think those are important to make this very clear about what they're looking at, because right now it's just unlabeled. But I don't want to put x-axis labels here because it's just going to muddle things up. So I'm just going to put x-axis labels on the bottom, and with the assumption that they carry up to the top. So here's how I do that. Again, a lot of this is the same, so don't think it's a ton going on here. The only difference here is I keep set visible to false on the ones in the first row, and then here I set visible to true on the two bottom ones, so set visual to true, and then on the bottom ones I assign what the labels are. So I'm saying use labels right here, and use that rotation again of 45, and HA, which I always think is funny, is that it actually stands for horizontal alignment, and that's important because if I use left, they don't line up nicely with the ticks. Horizontal alignment right means it'll line up with the ticks better. So if I run this again, same plot as before, but you can see now I get my nice labels down here. So I can say, oh, this is 51 to 100 here, this is 201 to 500 here, et cetera, and it carries across to the right side of my subplots. Okay, so that's everything that was part of topic 2, kind of getting comfortable with breaking your plots down into subplots. For plot 3, we're going to go a different direction and move all of my data for my different campaign statuses into a single plot so I can get a easier comparison. And I think this looks really nice here. That maybe not everybody agrees, but I'm going to show you this way, and you know, your mileage may vary depending on how you like things. So I'm going to put all of them into a single bar chart, a stacked bar chart, so I can see the variable heights of the different categories. Now this is a part where things get a little bit difficult just to understand, and it's one of those things that you get comfortable with and it's not too bad, but seeing it the first time is a little weird. But I'm going to do my stacked bar chart. To do a stacked bar chart, you have to keep track of where the first bar ends in each column, and then assign that to the beginning of the second bar. And then you have to track where the second bar ends in addition to the first bar to stack the third bar, and on and on. So that's what's happening here in this section of code. I'm going to step through this, and I actually print it here so you can get an idea what it looks like. But first, I'm going to just talk through it. So nothing's changed up till line 15 here. Figure 2 height is a variable that is I'm assigning as the bottom of figure 2. So when it gets stacked on top of figure 1. To figure out the bottom of figure 2, I just need to know the counts of figure 1. Because figure 1 is starting at 0 and going up to the bottom, or going up to where figure 2 would begin. So all I have to do is say, give me figure 1 data, which is state equals successful, and then turn it into a list, because I need a list to go through this stuff to get my correct counts. Okay, that one's not too bad. I'm just saying figure 2 starts where figure 1 ends. Figure 3 needs to be figure 2 plus figure 1. And that's what I need to know is the bottom of figure 3. So figure 3 height, I have to use something called zip here. And we don't really use zip much in the course, but all zip does is it allows you to do an element-wise calculation. So if you have two collections, you can do math between the two collections by item in the collection. So the first two items can do math together, the second two items can do math together, the third two items can do math together, and then you get a result. And then you can convert it to a list. So in this case, I'm saying just sum them up for figure 2 height, which we know is just the height of figure 1, essentially, and then add the figure 2 height. So I'm saying for the first bar, take figure 1 plus figure 2. and that becomes an item in my new list, figure 3 height, and then do the same thing all the way across for every one of those backer groups. Figure 4 height is the same thing, except this time I'm taking figure 3 height, which I just figured out, plus whatever the counts are for figure 3. So figure 4 starts where figure 3 ends. So these are all my variables that I had to create. I don't have to create one for figure 1 because it starts at 0. And then I'm going to print them here. I'll go ahead and run this. You can see the prints. So I end up here with these 3 lists. And each one of these lists gives me the bottom of the group that goes above it, or the plot that goes above it. So that's the difficult part of this one. The rest of it here, I just have to say, give me figure 1, which starts at 0, and then give me figure 2, but I add the bottom. I'm saying the bottom of figure 2 should start at figure 1's end, so we knew that. And then figure 3, its bottom is that figure 3 height. Now I'm not sure why I didn't use I created figure 2 height here. I didn't have to do this. I could have just said height. I don't know why I created it and I didn't use it. There we go. There. So each one of the second, third, and fourth figures uses those numbers that I calculated, and then I give it a label. So now I rerun this, and you can see I get this nice plot where figure 2 starts at the top of figure 1, figure 3 starts at the top of figure 2, and figure 4, which is so small you can almost not see it, starts at the top of figure 3. So I'd consider this a fairly decent visual, right? I can quickly see of each of the backer groups, every groups of less than 51 backers, I can see the breakdown. And that's a label mistake. 51 to 100, I can see the group, the sizes, et cetera, et cetera. So I can kind of, if I were to follow visually across, like if I was really looking at this, I could say, well, it looks like failed campaigns decrease as a ratio of the other categories fairly quickly as you move up to more backers, which we all know that makes sense, because the more backers you have, the more likely your campaign is going to be a success. But anyway, so I can do better than this, though, because I really want to make it a fair comparison. I want to understand as a ratio, as I get more backers, am I more likely to be successful? So we can do that. And I say here to really determine, okay, normalize all this data and make a fair comparison. Okay, so in this plot, I am going to normalize my data. So nothing's changed here, right? This is all the same. I have to figure out total height. I have to figure out total height to normalize. So what I'm doing here is determining, because I want to create a ratio, right? So I take the total of each of the groups, and then I divide it by the grand total to figure out what ratio or what percentage of the grand total each one of those categories takes up. Successful is 50%, failed is 20%, canceled and suspended are each 15% or whatever. That's what I need to know, that denominator number to do my division. So total height, I have to do, again, element-wise, because I have to go across to each one of my columns again, right? Because I have to figure out the math for each one of my columns. So I'm going to say, give me the figure 1 backer sum as a list, figure 2 backer sum as a list, figure 3 backer sum as a list, and figure 4 backer sum as a list, and then add them all up to figure out the total, right? That's how I'm essentially what I'm doing is I'm going through each one of my columns and figuring out the total height, and then assigning it to a list called total height. With that information figured out, I can now do my backer sum for figure 1 and divide it by that total height. And then I multiply times 100 to turn it into a percentage instead of a ratio. And I do that for each one of them. So that lets me figure out percentage-wise what each of these takes up for each of the columns. And then I have my figure 3 height and my figure 4 height here. Nothing's changed there, except I made it percentage-wise, right? Because they're no longer 40 or 50,000, they're 30 or 40 or 50. So I needed to use my figures that I just created, my variables that I just created, to figure out the heights. And then I do my labels as I did before, and then I plot the whole thing again. And you can see now, instead of having that decrease as I go across, you can see percentage-wise, percentage state for campaigns by backer count. As we move to the right, it is very obvious that successful is growing as in comparison to failed. So this is a really fair comparison to say, as I get more backers, am I more likely to be successful? Now it's very interesting, and this would require some further digging. You can see the yellow line here. It's kind of unexpected, right? I get these campaigns with a ton of backers, and then I suspend my campaign. That's kind of strange. I wonder if there's something interesting there worth digging into. I don't do it here, but it would definitely be worth going and figuring out what's going on, having a look at those particular campaigns and seeing why are those campaigns suspended. Maybe they bite off more than they can chew and they just give up, or maybe there's fraud or something like that. I'd be interested in seeing that, because that's a fairly large percentage at that size. But continuing on, I can do a little bit more here. I'd like to make sure that it's completely obvious what's going on. I'm going to put a count of the number of campaigns in each of those columns, because with this view, although it shows really well for ratios, it doesn't give a good view for how many are in each one of the buckets. So I want to make it obvious how many are in each of the buckets just by putting a count at the top. So there's not a lot here, again, that's different. This is all the same. And then my total height is the same. All this is the same. The only thing that's being added now is at the very bottom, I am adding this right here. And what this is doing is it's figuring out where the top of the top height is, and then assigning an output of total height. So I assign total height to Y value, and you can see it positions it in the correct X and Y position, and then it prints out Y. I'll just print it so you can see what I'm actually doing here. So you can see N equals 59,727, N equals 4103. That's what this for loop is doing. It's creating each one of these and placing them on the top of the bar. So I have to position it using something like this. So I'm saying center it over the top, vertical alignment's on the bottom, so it puts it above that, and no rotation, give it a good font size, and it does that for each of the bars. That's what this for loop is doing. So now I can see that although this all looks the same, if I look at the top, well, this category is much larger, or this grouping is much larger than this one, which we should expect. And then I think that might be also where I add my legend. And maybe I already have my legend. So I've got that nice legend there showing the labeling for each of the colors. This is something that you could very easily take into a meeting and explain quickly, and people would be able to draw conclusions from it. So this is a nice chart visual. Okay, so that's really the last thing I wanted to show you code-wise as far as making nice charts. The last group category there, I call it Matplotlib Wrap-Up, topic 4. However, what's really here is just a warning, because what often happens is as people start to grow into visualization and kind of get attached to it and want to share interesting visuals, they end up trying to create something overly complex. I don't know why. It's just a tendency. It's not limited to education. It's just everywhere. I can't tell you how many meetings I've gone into where someone has tried to create a fancy 3-dimensional view of something, and all they've managed to do is create a confusing visual. And what also happens is, because that visual requires so much of your audience's brain power, they don't hear what you're saying. So you kind of lose your audience. It's a really bad thing to have happen to you when you're trying to explain something. So I'm just going to say almost never should you create a 3D visual. There are surely reasons, maybe mathematicians or something that just truly needs to be 3-dimensional. But in 99 out of 100 cases, there should be a way to create either two-dimensional views or simplifying what you're trying to say into a 2-dimensional view to avoid creating a 3D plot. And no one should ever take a 2-dimensional plot and do one of those weird angle things on it where it tries to make the bars look like they're 3-dimensional, even though it's a 2-dimensional plot. Just don't ever do that. It's not worth it. Anyway, so that's my soapbox for today. But in this last part, I'm just going to show you that you can, even though I really don't think you should. I just took this because I never do three-dimensional plots. I do not like them, as I've made obvious. I just took this example. I think I put the link to it in Blackboard, but you can just paste this code and run it. But I'm using a special toolkit that allows me to create a 3D projection or a 3D chart to work on. And then I use PyPlot again, and I create just a random it's a random generation of data points, and I use a seed, so it's recreatable. Seed allows you to take random and actually make it deterministic, where every time you create random after using one of these seeds, you'll always get the same result. And then I create what is it, 100 points, 100 data points that are random in kind of a, I think it's just I assign the shape, and then it's distribution. And then I plot it. So I plot each one of the points. Again, this isn't something I would spend too much time worrying about, but here I'm showing you, look, I can create a three-dimensional plot, and look, no one could actually look at this and actually get any value out of it. Now, these are just random points, so realistically, if you had something that might actually mean something in 3 dimensions, fine. But as you can see, just you have to take the time to just try to figure out what in the world you're looking at here. In fact, this chart is really bad because it goes from 10 to 50, or negative 10 to negative 50, I guess is what's going on there. So negative 50 to negative 10. But you wouldn't be able to look at this triangle right here in the middle and have any idea of where it lives in XYZ space. It's just, it's a two-dimensional piece of screen where you're trying to show 3 dimensions. It just doesn't work. Now, there are other tools that you can make it so like it's interactive, so you could click on that point and see the data points for it. But again, I'm just pointing out that the situations where these things are useful are very rare. So please be cautious if you are thinking about using any kind of 3-dimensional stuff. With that, I am done with demonstrations for this week. You'll get to go create some visualizations of your own this week, and show me how impressive you can be with using plotting, because it's a very good skill to have. No matter where you are in using Python, there can be value here, whether you're just trying to show code runtimes based over time, or whether you're trying to share data outputs, you're trying to show ping times. There's a ton of different ways you can use this stuff. It's worth understanding at some level. Even if you don't have a deep level on it, it is worth understanding what you can do with it, so that at that point when hey, I need this, you know what's available to be able to build stuff.